Lecture 10, Presentation 2. How brainy is the third genus Homo? As noted, all Homo taxa have larger than ape-sized brains. All Homo species, except for Homo habilis, have the capacity to reach modern stature. Homo habilis was about the same size as Australopithecus and Paranthropus. But you must keep in mind that when it comes to stature, stature is susceptible to environment. Nutrition and activity in childhood, having certain diseases will impact the individual's ability to reach stature potential. This leads to a good question. Was Homo brain size increase simply a product of scaling effects? In other words, did brain size simply increase to the same degree as stature? So as people got taller, did their brains increase to the same proportion? Scaling effects result from proportionate enlargement. In the top row, the pizzas scale up and down proportionately in size. They show scaling effects. In the bottom row, the pizzas do not demonstrate scaling effects. Using chimpanzees as a control, we can assess relative increases in total body mass and brain size, cranial volume, in hominins. If brain enlargement is due to scaling effects, then body mass and brain size will increase proportionately. In the next slides, body mass and cranial volume data were obtained from multiple sources. Our focus does not concern male-female differences, and fossil species can be notoriously difficult to identify to sex. Therefore, I report the average for each taxon, including the chimpanzees, with the inclusion of data for both sexes. So in the top row, we have chimpanzees, both pygmy chimps and common chimps, and males and females. What are their averages for total body mass? 44 kilograms with a range of 33 to 60 kilograms, and for cranial capacity, 400 kilograms on average with a range of 282 to 500 cc's. For Australopithecus, at 35 kilograms in total body mass, it has about 80% of chimp body mass. But when we get to its cranial capacity, 453 cubic centimeters, that is 13% larger than we find in chimpanzees. Australopithecus species are 20% smaller than chimpanzees in body mass. In cranial capacity, however, they are 13% larger than chimps. Relative brain size is larger than predicted by body mass. It does not scale down with total body mass. However, absolute brain size does not exceed the chimp range and is lower than the threshold for apes. In total body mass, Homo habilis is nearly the same as chimpanzees, 96%, so it's only 4% smaller. In cranial capacity, however, it is 70% larger. Clearly, brain size is significantly larger than predicted by total body mass and does not scale with body size. And in total body mass, Homo erectus is 48% larger than chimpanzees. In cranial capacity, it is much larger than predicted by body mass. The brain is more than twice the size of the chimpanzee brain. Brain size increase does not scale with body mass. Yes, the earliest human brain size does not exceed the ape maximum size of 550 cubic centimeters in volume. But I must conclude that relative brain size in all hominins, even Australopithecus, is larger than predicted by body mass. Based on this, encephalization, which is brain enlargement, has been a hominin trend going back at least 4.2 million years ago. Brain size increase simply becomes more exaggerated with the appearance of Homo. But we've got to ask, does size really matter? We have already seen that early paleoanthropologists wrongly thought that larger than ape-sized brains were necessary for stone tool production. And with ape-sized brains, both chimpanzees and Pliocene hominins could solve problems by using organic and stone tools. Well, when we compare what modern humans can do with brains larger than a chimp's, the list includes linguistic and symbolic thought, creativity, and foresight. But be careful. Such cognitive skills are not simply the result of increased brain size. They are also due to changes in brain anatomy. For example, let's contemplate our frontal lobes. The modern human frontal lobe is larger and more complex than is a chimp's. Our prefrontal cortex comprises about 25% of the cerebral mantle, the gray matter covering the frontal lobe. In chimpanzees, it makes up about 15%. The prefrontal cortex is associated with mental concentration, organizational skills, and problem solving. This also explains why it is just devastating to an individual who gets any sort of damage to the front of the brain. And it includes a medial prefrontal cortex, it's buried deep within, that is significantly larger than it is in apes. In fact, until modern imaging, we didn't think that apes had one. This region is responsible for planning, memory, decision-making, and music and art. When did these brain changes arise? We will examine Pleistocene fossil crania for part of the answer to this question. In addition, we will consult archaeological data, artifacts. The evolution of stone tools is directly related to the evolution of the human brain. Homo habilis 2.4 to 1.6 megaanna, East Africa and South Africa. In the early 1960s, Lewis and Mary Leakey recovered fossils of a previously unknown species in Bed 1 at Old Divide Gorge, the same level that held Zinj, Paranthropus boisei, and Oldowan stone tools. In 1964, Leakey placed the find into a new species, Homo habilis, which translates to handyman. You know, the person that you call up to come fix the plumbing and uses tools. The species is now dated to 2.4 to 1.6 megaanna. Leakey's Homo habilis diagnosis was based on these specimens. And let me point something out for you right up here. These are cranial elements. They can be fitted back together so that you can get a cranial estimate or a brain size estimate. He estimated a brain size for Homo habilis that was larger than 550 cubic centimeters, in other words, larger than ape, and therefore a member of the genus Homo. So let's compare Homo habilis to earlier Australopithecus and ourselves Homo sapiens. And in this case, I'm using a fossil species dating to 31,000 years ago. So Homo habilis is in the middle here. Note Australopithecus with an average of 453 cubic centimeters in cranial volume, Homo habilis 680, and Homo sapiens at 1,350. Homo habilis brain size is intermediate. It is larger than Australopithecus but smaller than modern human. In recent times, a Homo habilis brain endocast was recovered at Kubifora in Kenya. In frontal lobe shape, Homo habilis is broader from side to side than Australopithecus. In addition, there is subtle enlargement of the Broca's area. Chimpanzees and Australopithecus are not developed in Broca's area. This is the region that controls motor production of speech, in particular the muscles around the mouth, around the eyes and eye orbits. Expression. Homo habilis Broca's area development is not absolute proof of speech. However, it certainly indicates increased control of facial muscles used for communication. Think about how much our faces can communicate without speaking a single word. I give you the following image. Is there any doubt that that little girl is happy? Homo habilis may have been the first human capable of face-to-face communication. Homo habilis adaptations. So here is an adaptive profile for Homo habilis. Geologic age, 2.4 to 1.6 megaanna. Geographic range, oldest in East Africa, most recent in South Africa, just like we saw with Australopithecus and Paranthropus. Body size short, 5 feet or less, none over 110 pounds, again, like Pliocene hominins. Sexual dimorphism, this is messy. We don't have a good record, so we're not certain. Brain size, on average, 680 cubic centimeters. So that's larger. Locomotion, early form of bipedalism, pretty much like Pliocene hominins. Habitat, mixed like Pliocene hominins. Diet, omnivory like Pliocene hominins. Tools, organic, Oldowan stone tools like Pliocene hominins. In most other respects, Homo habilis adaptations were very similar to Pliocene hominins, and like Paranthropus, it has been recovered in association with Oldowan stone tools and organic tools in East Africa and South Africa. And here we see Homo habilis using Oldowan stone tools to prepare food, and Oldowan tools are characterized by unfinished flakes and choppers. What do we mean by unfinished? The edges are not retouched or sharpened up or anything else. They're just taken as is. Now you are ready for Lecture 10, Presentation 3.